All right, so we are trying to wrap up our exploration of all of these trig functions. Spent a lot of time previously doing sine and cosine functions. And in the last video, the first part of this lesson 4.6, we looked at tangent functions and cotangent functions. And as I mentioned, I want you to at least see what the basic shape is and why that is. And we graphed those out and told you the good news is we can use a calculator. And we're also going to keep these just a little bit simpler because we're packing 4 of them into one lesson. So all we have left is to look at cosecant functions and secant functions. And I know that you guys remember, at least I hope you do, that cosecant is the inverse or the flip of sine. So if sine x was 2 over 3, cosecant x is 3 over 2. It's always going to be the flip of that. And the easiest way to look at these functions, y equals cosecant x, then is to first quickly graph y equals sine x. And then we'll look at inverting those values. So I think you guys are probably pretty good at this by now. But real quick, what we're going to do is we're going to start out drawing a y equals sine x. And I got my graph mostly labeled already. Just a basic sine graph has an amplitude of 1. We'll go up to 1, down to -1. It has a period of 2 pi, which I divided into 4 sections. And so sine starts at 0 and heads upwards. And we're at a maximum at the first increment. Then we're back at 0. Then we're at a minimum. Then we're back at 0. And the sine wave always looks kind of the same. And so there we go. Y equals sine x. What I want to look at then is taking some of these significant values and flipping them to get the graph of y equals cosecant x. Right here at 0, the sine is 0. Well, for cosecant, what's the flip? What's 1 over 0? Turns out we can't do 1 over 0. So for cosecant, right here, right along the y-axis at x equals 0, it's undefined. We can't graph it. So what I'm going to do is I'm going to draw me a vertical asymptote, just a dashed imaginary line. But that helps me to see what my cosecant's going to be. Remember, again, that was because sine was 0 and the flip of 0 or 1 over 0 is undefined. Well, I just want to look ahead and see that there's other places where the sine is also 0. Look here at pi, sine is 0. So I think for cosecant, I'm going to have another undefined part, a vertical asymptote. And there at 2 pi, I'm going to have the same thing. Now, let's look at this increment here. The sine of pi over 2 is 1. Didn't draw it all too good, but that's going to be my maximum point of 1. What's the flip of 1? What's 1 over 1? Turns out that's also 1. These guys, these two graphs are going to share that point in common. All right. The sine of 3 pi over 2 over here, the sine is -1. What's the flip of that? What's 1 over -1 is -1. They're going to share that in common. And what's going to happen is, because it's undefined here, my cosecant graph is actually going to come down from infinity down to this point, and then it's going to shoot back up to infinity again. So, like, in other words, if sine here at some point, sine, I guess, is like 1/3, the cosecant is going to be the flip of that, 3 over 1. It's going to be 3. And so what's going to happen, my cosecant graph is going to look like a big old smile. Okay, and it sits right on top of that that part of the sine. It looks like a big old smile. Well, the same thing is going to happen down low over here. It's going to come from negative infinity Remember, sine and cosecant are both negative at the same time. And it's going to be, now, sometimes we call that a frown, but I don't want this to be too negative sounding. So someone pointed out, well, it's also kind of the shape of a rainbow. So cosecant ends up just being smiles and rainbows, as the sine wave just kind of weaves its way up and down and up and down. The cosecant, y equals cosecant of x, is going to be a smile up above the positive parts and a rainbow down below the negative parts. And it's just going to continue on and on with a smile and with a rainbow. Okay. Smiles and rainbows all to the left and right. That's what the graph of y equals cosecant x looks like. And the nice thing about doing it, if we want to put in the A, B, C, and D values, is that we have our calculators. And I look at my calculator and I see a sine, a cosine, a tangent button. I don't see cosecant. But if I can just remember that sine, or excuse me, that cosecant is 1 over sine, I can make good use of that by putting it in my calculator. Let's take a look at one real quick. And we can either use our calculator or even without the calculator, because at this point, sine graphs are so easy to build. If you've done enough of them, you can probably do them pretty quickly. Because of that, I would graph out a sine graph. For any cosecant graph I was asked to do, I would graph out a sine graph and then use smiles and rainbows. I know it sounds like a simple thing to say, but that's going to get me my graph. Here's what they want us to do. They want us to graph y equals 2 cosecant 2x. And so what I want to do is, I know that cosecant is the flip of sine, 1 over sine. So I'm just curious, y equals 2. This part's not flipped. That part's not going to change. But if I did sine 2x, I wonder what that would look like. I think I could do that actually pretty quickly. All right, I'm getting good, I hope, at picking out my amplitude, the absolute value of 2, which is 2. So I'm going to go up to 2, down to -2. My b value here is 2. And so I know the period is 2 pi over b. 2 pi over 2. I think my period is going to be pi. And if I cut that into 4 parts, I have pi over 2, pi over 4, 3 pi over 4. All right, again, I know I'm looking for a cosecant graph, but I'm actually going to use a sine graph to easily find my cosecant graph. My sine graph goes like this: from 0 up to maximum, back to 0, down to minimum, back to 0. My sine graph looks like that. Well, please remember, cosecant, everywhere that sine is 0, the flip of that is undefined. So cosecant is going to be, let's do that in a different color. Cosecant is going to have an asymptote right here where sine was 0. It's going to have an asymptote right here where sine was 0, and over here an asymptote where sine was 0. And now I'm just going to do smiles and rainbows. Okay, this section here between 0 and pi over 2, I'm going to come from positive infinity, going to dip down so that these touch, and have myself a big smile there. Over here, I'm going to come from negative infinity. We're going to meet right there, and I have a rainbow. And so that's how I graphed y equals 2 cosecant 2x, right? If you want to use your calculator, right? If I wanted to graph this, I would do y equals 2, and then I would have 1 over sine 2x. So I hope you can see it would just be 2 divided by sine 2x. I could put that in my calculator and I would have a graph of cosecant. Y equals 2 divided by, or 1 over sine 2x. And my calculator can do the work for me, although it's pretty easy to draw a sine graph and to do smiles and rainbows. So real quick, let's look how cosine and secant kind of relate the same way. All right, let's y equals cos x we know amplitude is 1, so 1 to -1. We know the period is 2 pi. I'm going to divide that into 4 parts. And hopefully remember, cosine starts at the maximum, then the 0, then the minimum, then the 0, and then back to the maximum. And the cosine looks like that. All right. Y equals secant x is just going to be the inverse, the flip of y equals cosine x. So the same thing when we're flipping, I know that everywhere that cosine is 0, I'm going to have me an asymptote. It's not defined for secants. Right here, a 3 pi over 2. I'm going to have an asymptote. It's not defined. And then we're going to do the same thing. We're going to do smiles and rainbows, okay? Now, the thing is, since I started at 0, I'm going to come down here, and they're going to intersect right here. I didn't draw anything to the left. This smile would continue up over there. Here's a rainbow coming from -infinity and going back down to -infinity. Here's half of a smile anyway. If I were to continue the graph, I would complete that smile on the other side. So it's the same basic idea. Cosine and secant are inverses, are flips of each other. And so I can actually use a cosine graph and then look at the flips of those, figure out where my vertical asymptotes or where it's undefined, also figure out that they share high points and low points, and just kind of draw out my smiles and my rainbows. And so I'll let you practice some of those. And the homework, I'll print it up when I send out the assignment. It's also on the notes page 581, 582. We'll do all odd questions, 5 through 11, 17 through 23, 29 through 43. And I'd love you to do a mix of using the calculator. We have a calculator, might as well make good use of it. Also, maybe graph out some sine and cosine functions and use them to then get their inverses or their flips. For sine functions, we can get cosecant functions. For cosine functions, we can get secant functions. Give it a try. We'll come together on Monday. We'll deal with any questions that we have.